We have Kyle Stark, who is, well, he's with us, the Corps of Engineers. It says here also New Mexico Tech, so I guess I have to give them some credit because he did come from there. So he's going to be evaluating grain size. I'll stand on my tippy toes, how's that? He's going to be evaluating the grain size of bedload transported from Arroyos into the Rio Grande.
And Lynette's right, I work part-time for the Corps of Engineers, but I'm also a student down at New Mexico Tech, so I'm doing both, which is exciting. Thanks everyone. I think we've had some really interesting talks this morning, ranging from talking about what's going on from a water quality perspective in the Rio Grande to Ariane's talk, big picture, climate change kind of things. I'm gonna bring us back to thinking about sediment specifically in arroyos. So we at New Mexico Tech and Dan Cadal, who's here in the audience, we've been focusing on kind of how much sediment, how often, and how quickly sediment can move out of arroyos into the Rio Grande. And to do that, we've started monitoring the Arroyo de los Pinos, which, let's move out of Albuquerque for a second, all the way down to Socorro. And right just east of Socorro is the Pinos, and it's a 32 square kilometer watershed that is a direct tributary to the Rio Grande. And this is what it looks like. It looks like a pretty typical New Mexico arroyo. I do want to point out the grain sizes. I'm a millennial, there we go. The grain size kind of distribution in the arroyo. So we have a predominantly gravel bedded river. So about 2/3 of the river is larger than sand sized particles and about 1/3 is smaller. Which is really important for the types of instruments that we're using and the type of sediment that we're interested in studying, which is bedload. So most of what researchers on the Rio Grande and everywhere in the world study is suspended sediment. So that's the sediment that's suspended in the water column itself. But we wanted to try something a little harder, which is maybe not the best idea, but we're trying again anyway. And what we've done is we built this sediment monitoring station on the Pinos. This is what it looks like in from a drone image. Flow here is from right to left. And I've highlighted a series of instruments on this image. And this is great to kind of get perspective of the size of everything, but it's easier to talk about this in schematic view. So the same highlighted instruments here. We have a bunch of different things that we're trying out in the Arroyo setting. But today I'm just going to focus on these instruments. These are direct measures of bedload. And we use a system of reed slot samplers. And the way that reed slot samplers work is that as sediment rolls, slides, and skips down this channel, so remember bedload, stuff that's on the bed of the river, it gets transported downstream, and then it can fall into one of 3 different slot samplers. And as it falls into these slot samplers, it accumulates in this pit. And in this pit, we have a series of instruments that record that in real time, so then we can estimate a bedload flux in real time into the slot. So we have 3 of these, and let's look at some top level results. So these are all data from 2018. Justin talked about 2018 monsoons, and unfortunately we had 0 floods this past 2019 season. So all these data are from 2018. And these are the top level results. So on the y-axis here, I have bedload flux as measured in kilograms per second per meter width of channel. And then a shear stress on the x-axis, which is a proxy for water discharge. We use a reached average shear stress. So that's the amount of shear along the bed that's what gives the river its ability to move that sediment. And we have really high rates of bedload flux in arroyos. And that's been shown in Israel and other deserts around the world that you can get really high rates of sediment transport. I've highlighted the gray box down here. This is maybe what you might expect a range for typical perennial rivers, think the Rio Grande. We're doing some bedload estimates on the Rio Grande itself recently with the Corps of Engineers that hopefully we'll be getting some more specific results for that. But that's kind of the range that you might expect and a typical perennial river, a river that flows all the time. And the other thing to point out is that these samplers at these high rates, they have a finite space. They have about half a cubic meter of total volume. And so at these rates, those things fill in about 20 to 30 minutes. So we're not capturing the entire event, only that first flush of the flood. And these are really interesting. These are great. They're really cool. They all line up really nicely, these data points do. But the other thing that we can do is we can take those pit samplers after the flood. We can, because it's an arroyo, we can pull them out, and then we can sample that, and we can start to look at the grain size at these shear stresses. And we can compare those. And that's exactly what I've done here. The same axes, same bed load flux on the Y and shear stress on the X. And you can see at lower shear stresses, everything is kind of being transported equally in equal amounts. And then as we increase shear stress, water discharge, you see that the black line here and the red line here are kind of, you're seeing a lot more sediment being transported in those fraction classes. So that's a small gravel and medium gravel. And this is really interesting. So, as we think about the Rio Grande, we move out of our arroyo into the river itself. We can, we imagine the Rio Grande's got a lot of sand in it, predominantly sand bedded in most reaches of the Rio Grande. And now we can think about these inputs. So how do arroyos affect the Rio Grande itself? And this is an interesting graphic, but it's kind of hard to imagine. So what I've done is, this is exactly what that looks like. So this is after a large flood event on the Pinos. That's me in the background there. I'm standing in the Rio Grande. So this is as this big flood event from the Pinos has pushed all this sediment, all this gravel, and now it's kind of sitting in the Rio Grande there. And that's kind of, that dynamic is really what we're interested in. Because I'm interested in the Pinos. I think I spend a lot of time out there, but most everyone just really doesn't care about the Pinos. They care about the Rio Grande. So kind of that dynamic between the Pinos and the Rio Grande is kind of what we're trying to get at, and how we're trying to use a station like the one on the Pinos to kind of think about arroyos as a whole. Because remember, south of Albuquerque, there are no perennial inputs to the Rio Grande. It's all of these dry ephemeral channels. That is the primary source of sediment moving into our perennial system. So to kind of step back and think about kind of that interaction, the confluence there. This is a drone image, again, from 2016. Rio Grande is up here at the top of our image. This is the Pinos coming down the center. And that site I showed you is right about here now. 2016 wasn't there, so it's brand new, but that's where it is right today. So we're right there, we're right at the confluence. And you can see, I love these series of images because you can just see what a single arroyo can do to the Rio Grande. So we have a good idea of what's coming in, how much sediment is coming out of, let's say, Cochiti Dam. We have a good idea how much sediment is going into Elephant Butte Dam because we measure those things and we measure sedimentation down there. But again, what we don't really have a good handle on is this tributary sediment. So here, 2016, there's this nice bar that's formed at the confluence of the Rio Grande. And then by 2018, this is July 3rd, 2018, the Rio Grande does what rivers do. It's shifted itself, it's meandered all the way to its river left. So it's basically removed this bar, and 2017 was pretty good spring runoff here, so that makes sense that we've removed this bar and really it's kind of settled in on river left here. Later that summer, by July 29th, we could see the river's at a much higher stage here, so lots of input from monsoons. We could see that the river's shifted all the way back to river right. And that picture where I was standing in the background there, I was basically standing right here. The river had gone down by that point. We could easily walk all the way out here. And this is almost all gravel. So as soon as this sediment hits the Rio Grande, all that sand that's in our arroyo, because we have, again, about a third sand and smaller, all that can be efficiently transported out. And what we're left with is these pretty interesting gravel bars that we can use and monitor. By 2019, this is September 2019, river's really low again. We had another great runoff year in 2019. And you can see the river has shifted all the way back to river left. You can see some gravel here. There's some still leftover gravel that hasn't been able to move yet. But this is quite amazing. This is something I totally didn't expect the river to be able to do. I thought we had this great deposition of these larger gravels from a single arroyo, and I thought for sure the Rio Grande, much easier for it to kind of stay over here, at least for a while. All it took was one spring runoff to get back to river left, where clearly it wants to be. Hopefully it doesn't cut too far this way, then we'll start having problems. But so in this series of images, we can see two things. One, the sediment input from ephemeral channels is really important, and that's the dynamic that we're really interested in, specifically that bedload fraction. And two, the Rio Grande is really, really good and really efficient at being a river. It can dig its way through a gravel bar really quickly during high runoff years, and then get back to kind of where it wants to be, where it's just apparently right here on river left. So in conclusion, sediment fluxes are really high out of these ephemeral channels. That's a phenomena that I think we're really familiar with, especially those flood control authorities in like SCAFCA and AMAFCA. They have to deal with this every monsoon season. The sediment sizes that are able to be moved out of these arroyos, it's wide-ranging, of course, but it's also hyper-efficient. These are supply-limited systems. So, sorry, they are transport-limited systems. So they are really, really good at moving whatever sediment is put in front of them. And each of these events that I showed and kind of the data I showed today, those are only from a couple hours of flooding. I like to say we have about 24 hours of water in the Pinos every year, split between 3 or 4 events during the summer. Now, it's not every year. Like I said, this year, no floods. Had one small flood this year. This month. No, it's December. Last month, November, we had a small flood, but that's not the types of sediment moving events that we expect during summer monsoon. So it's highly variable, but remember, this is one arroyo on a network of hundreds or thousands of small tributaries that input sediment every summer. So that dynamic is, I think, what's really interesting to us, and that's kind of what we're trying to study here. So thank you very much. I'll be happy to take any questions, but it's also lunchtime, so I understand.
Very interesting. So I was wondering, it is pretty amazing that it can move that much, gravel. And how large gravel size did you get, or did you get to even an older size? And also, where's it going? Have you guys started looking at how far that gets transported down the river?
Two great questions. So first question, our slot width is 110 millimeters. So realistically, the largest size class we might collect is 90 millimeters, kind of that medium axis, that B axis. So we're not, certainly in those largest events, the largest event we've recorded on the Pinos, we're not getting the biggest boulders that are being transported, but we get up to, this size class in our slot samplers. So great question. Second question is kind of where that sediment's going in the Rio Grande. We haven't quite got there yet, but just the fact that it was able to really transport basically that entire bar that was deposited at the end at the mouth of the Pinos there suggests to me that it's probably moving that sediment pretty far down just in one spring runoff. And this was a really high spring runoff year, and it lasted a long time. So perhaps this is an abnormal year for that, but yeah, we're not quite sure where it's going yet. It's going downstream, but we're not quite sure how far. Sorry. No. Yeah. Well, thanks, guys.